Hey, everyone, come in the room, come in the room, come in the room. Today, I have a special treat for you. We're going to be doing a little calculus. We'll share my screen and show you this worksheet that we're going to go over and see if you can solve these related rates and optimization questions. So, without further ado, let's get into it, shall we? So the directions basically say solve each problem, show all work. So we're just gonna go for it. Okay. I give you time to read the question, or I'll read the question, and if you like, you can pause the video so you can have a chance to solve it on your own. And since we're live, why not see if you could tell me the answer before I actually even get it, right? So we're going to first talk about inflating a balloon. A spherical balloon is being inflated so that its volume increases at a rate of 18 cubic centimeters per second. How fast is the radius increasing when the radius is 6 centimeters? Now, there's a nice little hint that tells you what the volume of a sphere is, 4/3 pi r cubed. So that's nice. So don't leave you guessing, trying to remember that formula. It's right there for you. And so that's the volume of the sphere. So I'm going to draw a sphere, give you some time to solve this problem. Hold on. I'm looking. I just had it. Oh boy. Let's see. Let me see. Give me 1 second. I'll be right back. Oh, and I'll scroll down so you don't actually see number 2. We're just gonna do like one at a time. There we go. Give me 1 second. I'll be right back. Okay, I'm back. So here we have the inflated balloon problem. I'm going to draw my sphere. And I know how y'all love my drawing, so that's why I'm making it. It does look like how's that? That look okay? Okay. So we have the volume and it's increasing as it's getting inflated. And we're going to just assume that it's a perfect spherical shape even as it's inflating. It's just getting bigger, bigger, and bigger. So we need to take the derivative of the volume with respect to time. Okay, seconds lets us know that we're doing it with respect to time, so we need dv dt. Okay. All right, so what is dv dt? How fast is the radius increasing? Oh, guess what? We want to know dr dt because we kind of know the dv dt. So let me erase that question mark. We know dv dt and we want to find how fast is the radius, so we need dr dt. Okay, so that's one step in the right direction. Identifying our known and unknown quantities, right? And then labeling them with the proper notation. Okay. Let me see. So let's take it back to drawing. And we know that it's 18. And the RDT is what we want to find. Okay, so we'll use our equation. 4/3 pi r cubed. And then we'll take a derivative. So dv dt is equal to 4/3. Since it's a answer, use derivative of r cubed is going to be 3r squared, right? Bring down the power, subtract 1 from the power. Chain rule. Okay, we can kind of take that 3/3, 3 divided by, you're multiplying by 3 and you're dividing by 3. It's almost like you're not doing anything. That's a ratio of 1. And so you're going to be left with dr dt as well, right? So let me squeeze that in. Where'd you get that dr dt from? It just came out of nowhere. So when you have to realize that r is changing with time, the radius is changing over time, so we have to do it with respect to time. Okay, so once we do that, we can basically plug in our instantaneous radius. Our instantaneous value for the radius is 6 centimeters. And our dv/dt, which we know is 18. So we're going to say 18 is equal to 4 pi times 6 squared. And then we want to know what dr/dt is. So if we divide by the 4 pi and the 6 squared, then we can get the answer. Okay. And I don't want to quite, multiply this 3 squared because it's going to cancel with something in here, right? With the 18, because there's a factor of 9 and 1 within here. Actually, 36 is double that of 18. If that makes sense. Okay, so let's this way with it. Let's go this way and do our division, dividing by 4 pi 6 squared. 4 pi 6 squared. Okay. I mean, we could put 36, but let's just go ahead and do like this. Okay, so 18 over 4 pi 6 squared is actually 1 over 4 pi, and if we remove a factor of 18 from 36, what are we left with? Because 18 times 2, so we're left with just 2, right? We're left with just 2. It'll just be 1 over 8 pi over 8 pi. Okay, and since this is in per second, and this, which is centimeters, so it would be centimeters per second. Okay, just so we have the right units. Okay, let me know if you got the same answer. Let's look and see. One over 8 pi. Give this video a thumbs up if you are enjoying so far. Okay, we're going to go on to number 2. Filling a conical tank. So that's like a cone, right? Whenever you tank. Okay, so it's a tank. Let's just imagine maybe it's on a base, sitting on a base of some sort. And it's holding some water. Well, so water being poured in, water flows into an inverted. Let me see, what does it mean by inverted conical tank? I don't know what it means by inverted. Maybe it means it's upside down. Who knows? The tank has height 12. So this right here is 12 from here to here. It's 12. 12 what? Feet. Okay. And the radius, so from here out here, is 6. Let me change the color. So 6 feet going here. So that's half. The height is 12 and the radius is 6. So since that's a constant height and radius, we can say that that the radius is half the height. Right? If we want to give that distinction. How fast is the water level 5 feet deep. So this is an instantaneous value. How fast the water level is rising. That means the volume is increasing. We should give the volume, right? It's gonna be there's gonna be an h in there for a third power cube. I mean, let me double check that. One third pi r squared h. Okay, so 1/3 pi r squared h. Okay, and since we know that we can get it in terms of one variable, and we want to know how fast is the water level rising. How fast is it rising? So that's in terms of h, right? Um, and so the depth we call h. So that's changed. I'll put it h dt is what we want to know. Okay, so let's solve for h instead. That means h is 2 times the radius. Okay. Let me erase this ratio, this relationship, and change it around. And the other way is twice the radius. Okay, so we can replace the h with 2r. Oh no, we need to do it the other way. That's right. I was right the first time, y'all. Oh goodness. Okay. R. We place the R. If we replace the R, and then everything will be in terms of H, and then we can do dHdt because that's what we want. We want dHdt. How fast the water is rising when the water is 5 feet deep. Right? Well, we may not even need to do any substitution at all, but let's see. No, we do. So let's replace R with 1/2. So that's going to be an h cubed, and then this 1/4. So that's equal to 1/12 pi h cubed. Like I said, 1/2 times 1/2 is going to give you 1/4. 1/4 times 1/3 will give you the 1/12. And the pi stays there, and that becomes h cubed. Okay, so now we can take the derivative, dv dt, because it says water flows in. All right, so that right there is our dv dt. I should have identified that already, but anyway. It's equal to, we're going to keep that constant multiple rule, 1/12 pi. And taking the derivative of h cubed is going to give us 3h squared. Okay. The 3 and the 12 reduce to 1/4. And we can replace 4 for the dBdt. And 1/4 pi h squared. Oh, dHdt. Sorry, guys. I should have wrote dHdt because this is implicit differentiation. We know that H is changing, or the water depth is changing over time. Okay, let's go this way with it. And multiply by 4, we get 16. And then we divide by pi. So we're going to get 16 pi by 4. So you can see that. We divide by 4, the opposite thing is multiplying. So we get 16 equals pi h squared. Basically, we're trying to isolate h. We want to get h. Well, no, sorry, dHdt. So we can divide by pi. And we can also replace h with this instantaneous value here for 5. And that's going to give us 25. So we're going to get 16 over 25 pi equals dHdt. Okay. That is going to be our final answer because we can't reduce. There are no common factors here. Okay. Are there any questions so far? Did you get this answer? So I'm going to put in the answer for the first one. I'm going to say for number 1, the answer is the RDT is equal to 1 over 8 pi and then for number 2, we got 16 over 25 pi. Okay. Moving right along to number 3. A sliding ladder. So we got a 20-foot ladder that leans against a wall, and the bottom slides away from the wall at 3 feet per second. How fast is the bottom sliding down the wall when the bottom is 12 feet away from the wall? So let's make this picture. I like drawing pictures. And so I'm going to make this ladder here. while I'm drawing the ladder to see if you can solve it before I do, you can pause the video and try it for yourself. Okay. We know that this ladder is 20 feet. It's leaning up against the wall. And we say the bottom, well, the top is sliding. Okay, hold on. The bottom slides down. The bottom slides away. Okay, let's call this X. Let's call the height Y from the top down. From the top down to the floor. Okay, so if the bottom is sliding away at 3 feet per second, how fast is the top? So we want to know dy dt. So dy over dt is what we want to know. Okay, so this is dx dt. And this forms a triangle. So if this forms a right triangle, you can use the Pythagorean theorem to figure out how fast the top is sliding down the wall when the bottom is. So when is that instantaneous? The bottom is 12 feet from the wall. So when the bottom is 12 feet from the wall, that means the instantaneous value is x equals 12 feet. Okay? Okay, so knowing all of this, we got our knowns, our unknowns, what's changing, and what we want to find the rate of. So we can first set up our formula, and that is x squared plus y squared equals 20 squared. Okay, so we could take the derivative implicitly. We can say 2x dx dt plus 2y dy dt is equal to 0. The derivative of constant is 0. Okay? And since we want dy dt, we're going to get dy dt by itself. But we notice that there's a 2 in common. And when we divide out by 2, we just get x dx dt plus y dy dt. So we don't have to keep multiplying by 2. Okay? So we're going to just divide by 2. And we're left with x dx. Well, yeah, let's do that. X dx dt equals 0. So we'll x dx dt over to the other side and divide by y. We are left with, and we're going to say that dy is equal to, and if you need me to break it down further, certainly, connect with me afterwards. Do tutor camp you can book.me, schedule a private tutoring session. I will be glad to break it down some more if you're not understanding, if any steps that I might be skipping and just talking through confuses you, definitely get with me and I will help you step by step and break it down even further. Okay. So this is subtract x dx dt and divide by y. And then we can replace the values, instantaneous values. Okay. So the instantaneous values will be x equals 12. And if x equals 12 and the ladder is 20, what would y be in this case? So we can do our Pythagorean theorem. We're going to say y is equal to the square root of 400 minus 144. Okay. And that's equal to, let me get my handy dandy calculator. $256. Ah, that's nice. Square root of 256 is 16. Okay, so y is 16. So dy dt is equal to minus over 16y. And then dx dt, we're given is 3. Okay, so it's going to be 36 over 16. Okay, we can reduce it by 2. There's a common factor of 2 there. So 6 over 8, so 18 over 8 minus 18 over 8. And the units on that is going to be feet per second. Okay, so that's dy dt. And that's how fast the bottom is going down. It's sliding down 18 over 8 feet per second. If we change that to a mixed number, it will be about almost 3 feet per second. It will be 2. So it's sliding down a little bit slower than it's sliding away, but almost the same. Okay. Any questions to this point? Okay. So I'll put the answer for number 3 here. It's 18 over 8 feet per second. I actually didn't put the units on the other ones. There you go. Let's do another one. Well, actually, you know what? I'm going to just show this one. I'm going to see if you can answer it. I'm going to leave it as an exercise for you to do. Let's see. Because we've done 3 so far. So I'm just going to read through it. I'm going to help you set it up. And then I'm going to leave it for you to answer. Okay? So we got 2 cars at an intersection. Okay? So there's the intersection, and there are 2 cars at the intersection. Let me change my color. Okay, we got 2 cars. Okay, so car A traveling east Okay, it's going east, 40 miles per hour. Car B is going north, at 30 miles per hour. Now, both of them leave the intersection at the same time. Okay, so we know where that time is changing. How fast is the distance between the cars increasing? So the distance is going to form a triangle. There's a right angle there. And wants to know what's happening after 2 hours. Okay. So after 2 hours, we can figure out how many miles they've gone by just multiplying the speed times the time. That gives us distance. Okay, remember distance is speed times the time. Okay, so that's going to help you there. And then we want to know how fast it's increasing 2 hours later. So this is what we want to find out. dZdt. Okay, so we got a y, we got an x. We want to find out dZdt. Okay, so this is growing. X is changing, y is changing, z is changing. So we want to find out. But that's actually, I drew an arrow there, but I need to maybe move this over. Let me just move this unknown over so I can put the known. Well, oh yeah, well actually we are trying to find that, right? Yes, that is what we're trying to find. We're trying to find how much is changing. Okay, so I apologize. That's Z, but this is Z. And we want to find dZdt. So what formula do we need to take the derivative of? Well, we need to take the derivative of the Pythagorean theorem, right? Z squared is equal to x squared plus y squared. Okay, so once we take the derivative implicitly, so we have everything with respect to time. These are all time dependent. So we can find dZdt. We'll take the derivative. I'm gonna leave this for you to work out as an exercise. So put your answer in the comments. Okay? All right, let's look at number 5, the last one. And I think I'm going to also set this one up for you and let you do it and put your answer in the comments. Yeah, that's what I'm going to do. And with the optimization, it's not a long video, but also I'm going to do the same thing for the last two questions of part B, the optimization questions. Okay, so we got a 6-foot person that walks away from an 18-foot street light. So let's just say the street light is 18-foot. Street lamp. Okay, so it's shining its light. Light shines against a 6-foot person. Right here. Okay, so not down here, but this person. Look. Okay, so my person is 6 foot tall. So the height here is 6. Okay, so that height is 6, and the lamp is 18. And so there ends up being a shadow on the ground. Okay, the shadow on the ground also has a its own height. And do we know? Just call it S for shadow. That distance is S, and the distance here we'll call X. Okay, how fast is the length of the shadow increasing? So as they're walking, 18 well, away from the street light at 5 feet per second. Okay, they're walking away at 5 feet per second. This is the length of the person's shadow increasing. So we want to know dt down here. So what is ds dt? Okay. We know the lamp and the lamp, they share this hypotenuse of the bigger triangle. So we're going to use similar triangles to determine this relationship and to get our formula. Okay, so 18 x plus s as 6, the little triangle inside, is to s. And we really want to find out this s. We can move the s to the top. We can say 18s is equal to 6 times x times s, x plus s. Okay, and if we distribute the 6, we're going to get 18s is equal to 6x plus 6s. subtract 6s so we can combine like terms. We got an 18s over here, 6s over there, and we want to combine like terms to get, I'm just moving on up here, to get 12s is equal to is equal to 6x. So we divide by 12 and we say s is equal to 1/2 x. Okay, we'll take the derivative to time, and now we can figure out what ds dt is when we know that dx dt is 5. So that's the instantaneous rate at which x is changing, increasing. Okay, so I'm going to leave that also for as an exercise. I'm not going to take the derivative or plug in any values. Go ahead and comment the answer when you get it. Okay, we're going to start with some optimization questions. Let's see. I'm going to leave 4 and 5 for you to answer and leave in the comments. Okay. All right, let's see. Next up, we have a rectangular garden. A farmer has 600 feet of fencing. Okay. One side borders a river. So we'll just say there's a river. So no fence is needed there. But there's some other sides. The border. And we want to maximize the area. So what is the maximum area here? So the max area. Okay. Right, so the area of a rectangle, hold on, yeah. The area of a rectangle is length times width. Okay, and we know the perimeter is equals 2 times the length plus 2 times the width. But if we say this is the length and this is the width, we only have one width that we need. So the perimeter is actually just 2L plus W in this exercise. Okay, so the perimeter is all the fencing that we need, and we're going to use 600 feet for that perimeter. So we can say that is equal to 600 feet. Okay, let me take that. All right, so 2L plus W equals 600 If we want, we can get our area in terms of just one variable. We can get it in terms of W, or we can get it in terms of L. What do we want to do? Okay, it says determine the dimensions. So we need L and W. So it really doesn't matter which one we solve for. We can solve for L or W, but since W doesn't have a number next to it, let's just go ahead and solve for W by subtracting 2L. So we'll just say that W is equal to 600 minus 2L. So A, yikes, is equal to L times 600 minus 2L. So if we distribute the L, we'll get 600L minus 2L squared. Now we could take the derivative. We're going to take the derivative. That tells you how the area is changing with time. And then after we take the derivative, then we're going to set it equal to 0 to find the maximum values. Okay? So let's do that. Okay, sorry. I don't know why I say, okay, let's just say A prime is equal to 600 minus, let me fix that prime because that looks like a 2 almost. Is equal to 600 minus 4L. Okay. All right. We set that equal to 0 to get the maximum. And we solve for L, and then we can find out what W is using this formula right here. All right, so we can move the 4L to the other side, divide by 4. Let's give us 150. 150 times 4 is going to give us 600. So we know that L is equal to 150. If I did it too fast, if I did it way too fast, definitely book a session with me, tutorcamp.youcanbook.me, and I will break it down for you. Okay? Basically, I move the 4L to the side by adding 4L to both sides. Then I divide by 4 to get L equals 150. Okay? Now, if L is 150, then W is 600 minus 2 times 150, which is 300. So 600 minus 300 is 300. So those are the dimensions, 300 feet and 150 feet. Okay, I probably should have made the box around the feet symbol, but it's okay. You get the point, right? Okay, so let's go ahead and put that in the chat. For number 6, the length equals 150 and the width equals 600. Oh, hold on. What did I say? 300. Okay. That's number 6. All right. Let's move right along to number 7. An open top box. Okay, open top box. So we got a box. And it's open. There's nothing in it. Maybe some paper or something. I don't know. But it's open. That's what we want. We want to open top. Anyway, a 20-inch by 16-inch piece of cardboard has equal squares cut out. Paper. Cardboard. Piece of cardboard. And it's 20. And so there's coin that makes this open top box. Okay, this we don't know how many. I'm just guesstimating. You know how much is cut out. The sides are folded upwards to form the open top box. Find the dimensions that maximize the volume. So, it's gonna get folded here. It's gonna get here. And get folded here. And it's going to get folded here. So that's, you're going to see the fold, right? Okay. We want to maximize the volume, like how much is in here, length times width times height, right? That's the volume. That's what we want to maximize. And there's something we already know about the length, width, and height. We can get it all in terms of a variable or 2 variables. I'm trying to think. So if we cut out the x, all right, we can call them x since they're equal squares. Since the x of the little squares is x squared, right? And so the length, this is the, and then the height is going to be x. H equals x. The height is however much we end up cutting. All right, so the volume is actually going to be 20 minus 2x. The width is 16 minus 2x. And the height is just x. Okay. So we really have a cubic equation that we're going to take the derivative of once we multiply this all out. So let's start by distributing this x here into there, and then multiply times 16x. Okay, now we're going to distribute. We're going to use the binomial expansion because we got two terms in each factor. Okay, so 20 times 16 times x. That's the first. Minus, we're going to do the insides, which is 32 x squared. And then the outsides is going to be a minus 40 x squared. And then the last is going to be a positive 4x cubed. Since we have that, in terms of just one variable, x, do that. Volume is equal to, and I'm just going to leave this 20 by 16. Or do I want to, okay, 320, because 16 times 2 is 32. And then add a 0. That was not that bad. 20x minus how many x squareds? Minus 32 and minus 72 x squared is 4x cubed. Okay, so v prime is equal to 320 minus 72 times 2 times x plus 4 times 3 is 12 x squared. Okay. All right, so we got the derivative. We want to set it equal to 0 so we can maximize, find our critical values. Let's do that. Okay, so what happens when we combine these two, 72 and 72, 140 something, 144? So I'm going to kind of come up here and say, what we can do is we can do, yeah, let's kind of reduce this down a little bit. Let's take half of everything at least. We might be able to take even more than that, as we can, depending on the common factors. And see. Okay. Let's see what the common factors, the greatest common factor, maybe 4. Could have took a 4 out. Okay. If we take a 4, we get 80. Minus 36. Or is it 32? Let's see. 36, 18. Oh, it's just going to be 72 if we took out 32. But if we take out 4, sorry, my bad. We're taking out 4. So we take out a 4, it'll be 36. Yeah, I was right. I was thinking too fast and answering, and then I was like, wait, hold on. All right. plus 6. Okay, and that's equal to 0. Okay, all right. Now better, but that wasn't the greatest common factor because everything is still even, right? So we could put a 3, 18, and 40. And then we can use the quadratic formula, or we could try to factor. It really all depends what you want to do. Let's just say A is equal to 3, B equal to 8 minus 18, and C is equal to 40. So X is equal to plus or minus the square root. Let's put a plus or minus here. Square root of, hold on. Wait 1 moment. Okay. Let's say quadratic equation is minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, that's x. Okay. So since b is minus, we're going to make it a polynomial plus or minus square root of 8 minus 4 times 3 times, oh wow, boy, hold on. I hope 18 squared is more than 12 times 40. Let's see. That's 324 minus 480. That looks negative. That's not. So I did something wrong. Let's just start. Let's just break it down a little bit better. I'm gonna erase this. No, we definitely want the wrong answer. Because it has to be positive. We can't have negative area. And we can't have imaginary roots. So definitely want to fix that. Let's see where I messed up. I just wish I could wipe it clean because it's not erasing. So that's number 7. Hi, Real AV1. Okay. Let's see. Still trying to erase all the stuff. The eraser is not working well for me. Okay, so to be honest, we could take out a 2 from all of this. But anyway, let's just do it how we do it. 20 times 16. Let me double check that. That is 320. I was right. Yeah, I was definitely right about that. Just gotta make sure. 320. And then minus 72. X squared plus 4x cubed. And v prime is equal to 320 minus 72 times 2 is going to be 144. X plus 12x squared. Now, if we take out a 4 in all of these, then when we set it to 0, I think that's where I messed up. B is not 18 because 144 divided by 4 is not 18. So that's where I messed up. So 44 divided by 4, 48, right? So that's 12, 24. Oh, 6. I did have 36. Okay. So it was 80, 36, and 3. Okay, so 0 equals 80 minus 36 x plus 3x squared. Okay, so that's about as far as we can go because this is odd and that's where I went wrong. I'm not sure. Yeah, I think I might have broken it down a little bit more than I could have because I ended up with an 18. Okay. Okay, so let's do with this. Let's say A is equal to 3, B is equal to minus 36 is equal to 80. That's a little bit better. So x is equal to 6 squared minus 4 times the 3 times AC 80. I still feel like that's bigger, but 36 is really big. So let's see 36 squared. 1296 minus 320 times 3. That's 960. Okay, that's better. It's going to be positive at least. We're going to divide by 2 times 3. We're going to divide by 6. So we're going to take the square root of that plus or minus positive 36 and divide by 6. Okay. So I got 36 divided by 6 is 6. 6 plus or minus the square root of what's 1296 minus 960? 336. Ooh. Okay. So if that's x, let's see if we can split up 336. 336. Half of that. Wait. 1, 6. By 2 is going to give us 80. Oh, wow. Hold on. It's a lot of 2s. Okay. 84. 41. 42. That's a lot. So let's look at 336. Is 2 times 168, which is 2 times 84, which is 2 times 42, which is 3 times 7. Okay, so whatever the square root is going to be 1, 2, 3, 4 times 4. The square root of 16 is 4. So we're going to put all 4 with 21 on the inside. Okay, so it's 6 plus or minus 4 square root of 21 over 6, which is going to be 2/3. It's going to be equal to 6 plus or minus 2/3 square root of 21. Ooh, that's a little messy. But we can estimate 21 be close to 4. well, it's going to be 4 point something, right? Because square root of 25 would have been 5. So it's going to be around 4. So that being said, we can still plug into our formulas for L and W, right? So if X, we want to find the dimensions. Let me erase some stuff so we can put in the dimensions. So I'm just going to put it over here. Come on, erase already. I'm going to change colors and just start already. I'm going to put a green, and basically I'm going to put it up here. And I will say that L is equal to 20 minus 2x. And we know that x is 6 plus or minus 2/3 square root of 3. Now we could, sorry, 21. We could just use a decimal point. Me being an anal retentive exact type of value kind of girl, I like to, I don't mind using square roots. So I'll leave it like that, and I'll say W is equal to also 6 plus or minus. So how do we know which one plus 2 square root of 21 divided by 3, or is it 6 minus 2/3? That's the question. Now, we can like make more sense, right? Because half of 20, 10, if it's somewhere around 10, we know that that's not right. If it's somewhere around, if it's gonna make x close to 10 or close to 8, then yeah, no, we're not gonna do that. Does that make sense? We don't want it to be close to 10 or 8. Okay, so let's keep going. I did 2/3 square root of 21. Okay, so 6 plus 2 times, let's just say it was 4, right? It would be 8/3. 6 plus 8/3. It's gonna be around 8. That's not right. It can't be more than well, L 16, 20 minus 16. It can't be that. L can't, well, it's possible. 20 minus Um, 16 is like 4. Okay. If we subtracted 2/3, if we subtracted 8/3, then we'd be close to 2 times, right? So, okay, let's go ahead and estimate. We're gonna say plus or minus 2/3 square root of 21 is going to be 18, which is around 10. If we subtract, it's around 10, but it's around what? 20 something? So we have to add. Because if we subtract, that would be wrong. So this is the estimation. We don't want the one that's 10. We definitely don't want the 10. Right? Um, well, x can't be that long either. It can't be greater than 20. It can't be greater than 16. 18 minus 8 is 10. If x was 10, though, that would not be good because that's, like I said, it's going to be half. It's going to be half, and we won't have any area. Interesting. Okay, so but if it's around 10, 20 minus 20 will be 0. See? And we want to maximize the volume. 18 plus 8 is 26. 20 minus 36 is going to be negative. Same with that. So something's not right. Okay, so let's skip this problem because let's see if you can do this problem. Apparently I did something wrong from the beginning. Oh, hold on. Is it 2 times x? The length. Yeah, it is 20 minus 2x. Because here's x and here's x. 20 minus 2x. And then 16 minus 2x. Mm. 32. 40. Not seeing it. Okay, let me double check my work with the answer key. Okay, guys, give me 1 second. Okay. Oh, I didn't divide by 3. So this right here, I didn't divide by 3. So if I took this to be 6 plus 2 times 4, which is um, let's just say it's 18 plus 8/3 or 18 minus 8/3. I think it's like that. So 18 plus 8 over 3, and then 18 minus, multiply both sides by, I'm going to multiply by 3 to get a common denominator. So it'd be 26 divided by 3, or 10 divided by 3. So which one do you think? It's going to be about 8. And then this is going to be about 3. So it's best to be 3, close to 3. Okay. Instead of 8, because 20 minus 4 and 20 minus is 14. So that's going to maximize it. So we're not going to take the plus, we're going to take the minus option. Okay. So it's going to be 18 minus 2 square root of 21 over 3. That's what it was. That's x. Okay? Okay. So if we did that, we estimate it to be about 3. 3 point something. Then we would say that the length 20 minus 6 is about 14. The width 16 minus 6 is about 10. And x, or the height, is about 3. Okay, so something like that. So that will be the dimensions that will maximize the volume. Now, these are all estimations. You want exact values, you can calculate the exact value, and we can discuss it. Go ahead and put it in the chat, in the comments, so we can look at it. Okay? All right. So for number 7, the length is about 14. W is about 10, and height is about 3. So somewhere around there. But if you want to give me exact values, that's fine too. You can give me exact values. Okay, let's move right along because we spent quite a bit of time. Hold on. Oh, I called it 7, but actually it started over for phase or part B. Okay, so my bad. That's 7. I mean 8. This is 8. Number 3 is 8. I call this 7. And then I'm going to call this 6. Okay? Since I labeled that inside of the chat. Okay, and okay. And it has to hold layers. That's the volume. Right? Top. Okay. So let me just go ahead and change my color here. The material for the top and the bottom costs twice as much per square centimeters. Okay. As the material for the side. So the side right here, like if we were to cut it open, flatten it out, that's the material for the side. So that will be the height. So let's say the side is going to be the height times the perimeter. So the circumference, the circumference is 2 pi r, right? Circumference equals 2 pi r. So that times, so the side is going, the area of the side material is going to be, I just said it, the circumference times the height. Okay. Let's see. And that is the material for the top and bottom costs twice as much. So it costs twice as much. So the top and bottom, add those two together. T plus B. So the cost of T plus B, it costs twice as much per square centimeter as the material for the side. So 2 times the area. Okay. So the cost of T plus B is 2 times the area. Okay, well, 2 times the cost of the area. Hold on, let me go. Let me undo that and let's fix that. Equals 2 times the cost of the area. Okay. So the cost of the top is a circle, right? And so it's going to be, the area of the circle is pi r squared. 2 pi r squared. Okay. Yeah, let me erase that. It's kind of okay. All right. So that's that. Radius and the height that minimize the total material cost. Okay. We want to minimize it. See if we can figure out what we're talking about here. If we minimize the area, then we can, so the total area, let's just consider the total area. Total area. I'm not even going to use T's. I'm just going to say area. That we want to minimize, right? We know that the area hold on. Okay, so it can hold. So we need to compare that to the volume, right? Since we have the volume, let's find the volume of a cylinder, which is pi squared h. All right. Pi r squared h gives us the volume. Yeah, it's just like saying a whole bunch of disks h times, right? Um, hmm. Equals, it's really kind of like the surface area, total surface area. It's going to be 2 pi r squared plus 2 times 2 pi r. No, what is the height? It doesn't say what the height is. H. Not 2 pi r, 2 times 2 pi r, but 2 pi r times h. Because we don't know what h is. Okay. Let me just erase that. Okay. Okay, how can we use the material cost? We can use the area of the volume, right? I think the reason why I want to say 2 times is because of the side. But the side was really the circumference times the height. Yeah. So the cost function. So let's do that. We want the radius and the height. So the radius, um, 'Then R is equal to H. R is equal to H. Square divided by R is going to give me R equals H. So since we know the 500 is equal to pi R squared, 500 pi squared, we do dividing. Okay, so V prime equals pi r cubed. And so they're both the same. It's going to be 3 pi r squared. Yeah. Third. Okay. So let's see. Um, 500 plus pi r squared 8. Yeah. Okay, I was right. But I should have taken the derivative of the cost function and not the volume. Okay, so that's what it was. That's what I did wrong. So let's go back to it and fix that. Erase that. Okay, let's call this cost function. 2 pi r h, 4 pi r squared. So it's going to be 2 times the pi r squared. Let's make it look better. Okay, so that's the cost function. All right, so we know that 500, yeah, so h is equal to 500. That's the relationship between r and h. Okay. I'm thinking that if h is, okay, so we got 4 pi r squared plus 2 pi r times over pi r squared, right? So that's equal to 4 pi r squared plus over, okay, so c prime 8 pi r plus, hold on, what's the derivative? Yes, it's going to be minus 1,000 over r squared. When you bring down the, that's minus. That's what makes it minus, because it was going to be minus 1. Okay. That equal to 0. If we can add that to both sides, over r squared equals 8 pi r. So 1,000 8 pi equals r cubed. So is equal to cube root of 1,000 over 8. Oh, and that comes out really nice, because that's, no, not really. It's still cube root of 1,000, and but the 8 is a perfect cube, so you can pull out a 2, 1/2. Okay. Anyway, let's see if I got it right. Yes, 1,000. I was right. Okay. So if you plug that into your calculator, you should get about 3 for R. Okay. So it's about 3.4. And then if you plug that back, the plug, let me just R in here. Then you get H equals 500 divided by pi 3.4 squared, which is approximately 13.7. Yeah, there you have it. I know that looks like a lot. Like I said, I could definitely break it down a little bit better for you in a one-on-one. But that is what it is. So we got a rectangle under a parabola. Rectangle under a parabola. Okay. Y is equal to 16 minus x squared. So maybe this is 4. Maybe it's minus 4. Oh, I see, but the parabola is like that, not up. That's why it's inscribed. All right, and I put 16 when it should have just been 4. Okay, y equals 16 minus x squared. Nope, let me take that back. That's gonna be 16 minus. Okay, so 16 minus x squared is gonna be like, and then 16 up here, and then minus 4. I mean, that's positive 4, and that's minus 4. Okay, and then there's a rectangle up under it. Okay. So we want to see, find the dimensions of the rectangle having the maximum area. So basically, what is this, right? What is this and this? That's going to maximize area. So we're going to get x and x here. And then the height will be y. Interesting. What is the area? The area is y times 2x. First times the derivative of second plus, oh, um, oh, I didn't write the answer for number 8. R is about 3.4. H is about 13.7. Okay. I need to fix it. Okay, so let's start over. I want to draw my picture very clearly and make everything look nice. We have a parabola. And it's up at 16. Right? So we know that the height, the maximum height, could be no more than 16, but it's definitely going to be less. Definitely going to be less than 16. For the height of the rectangle, or for the length of the rectangle, and because we want a rectangle that's going to be in here. Okay. I want the maximum area. So the area, and it's going to be x here and x here. So it's really going to be 2x. is going to be y. And this is 16 minus y squared. I mean x squared, sorry. Okay, so area is equal to 2xy. And we need to maximize this. Well, we're told that y is 16 minus x squared, so we're going to just replace y with 16 minus x squared, so we have it all in terms of one variable. Okay. So what we can do is we can distribute, and we'll have 32x minus 2x cubed. A prime is equal to 32 minus 6x squared. And we said that equal to 0 and solve for x. So 6x squared equals 32 divided by 6. And we say that x squared is 32 over 6. Well, since 32 is not divided by 6, it's going to be some multiple of 2. So 16 over 3. So if x squared is equal to 16 over 3, then x is equal to it's going to have to be positive, so we have to take the positive version of 4 over square root of 3. And if we rationalize, it's going to be 4 square root of 3 over 3. That's x, and y is equal to 16 minus x squared. Okay, so everything in here has to be squared. 16 over 9. 16 minus 16 over 9 times 3, which is going to make this go into 16 minus 16 over 3. 48 over 3. 48 minus 16. 32. Okay, so that's your x and y. That's going to maximize the area. So it's going to be around, it's going to be around 4. And then the height 8, 9, 9. So, no, that's close to 10. Yeah, it's 9 point something, but it's close, really close to 10. So, if this is 4, it's minus 4. So, yeah. 4 square root of 3 over 3. And then 32 over 3. Okay. This is about 10.6. All right, so that's on. I'm going to go ahead and put the answer. Wait a second. It's not a 0.6. Hold on. 32 divided by 3 is 10.6? Oh, it is. Yeah. Okay, my bad. Yeah, I was right. That's right. That's close to 11. 10.7. So 10.7. So y for number 10. I mean 9. 9. Y is about 10.7. X is about um what could I say about it? I don't want to say that. It's close to 4, 4.6. Okay. Because apparently square root of 3 over 3 is about 6. Or something like that. I don't know. Um, it's gonna be close to 1. Okay. Now let's see. The last question. Norman window. Ooh. I actually haven't done this question before. So this is the reason why it's taking me longer than most time, because I really haven't done it. And I'm just like enjoying the process. Um See, I'm not coming to y'all prepared and everything. But I just got the worksheet and I said, let's do it. So a Norman window consists of a rectangle topped by a semicircle. So we got a semicircle and then a rectangle. Something like that. Okay. So that's the window. The total perimeter is 24 feet. So all of this all the way around. Let me see if I can give you enough color. So the perimeter all the way around equals 24 feet. Determine the dimensions that maximize the area. Okay. So the area is going to be half of pi r squared. And then it's going to be, let's say 2r, that's the diameter, times h. Hold on, 1/2. Why did I do that? I don't know why I put the equal in between there. The area is going to be 1/2 pi r squared. That's the semicircle, half of a full circle. And then you're going to have to add the area of this rectangle, which is 2r times h. Okay? So that's that. So that's the area. We want to maximize it, so we can say that A prime is equal to pi r plus, well, what can we say about this? H business. Do we need to do something to it, or keep H the same and make it a product rule? Interesting. First times 0 second plus second times 0 first. So 2r times 1 plus h times 2. And then we are left with pi r plus 2r plus 2h. And okay, so we're going to say you said that equal to 0? We want to maximize the area. What do we know about that? Do we want to make h equals r? That would be a square. That would definitely maximize it. Oh no, if h was 2r, that would maximize it. Because square maximizes a rectangle. So I can let h equals 2r. Or if I left it in general and said that h is equal to there's no minus. I don't think I need to do that. I could find out what R is if I didn't do that. So if I let H equal to R, then 2R equals minus R 5 plus 2 over 2. So for R equals minus pi R plus 2R. So it's going to be, wait, what? Um, 4R. Okay, so 4R plus pi R. Totally not going to be good. Okay, let's see what the last one says. Oh, hold on. Okay, so the normal window. Oh, we're told the perimeter. Why didn't I use the information about the perimeter? Okay, so P. So the perimeter. Interesting. So that's not including the inside. I'm not really sure. Because I know the semicircle is 2 pi r, right? That's, and then half of that. That would be the perimeter of that. And then the perimeter of the thing is going to be 2 times 2r plus 2h. And if that's 24, then we get r times h. or vice versa, right? Then we won't need to do the product rule like I did. It wouldn't have been like that. So let me fix that. So we would say that 24 minus 2h. No, let's say minus 4r, right? Divided by 2 equals h. Okay, so we can take 2 out of everything and say 12 minus 2r. Okay, so h is actually 12 minus 2r. And I'm going to change the color. And so before I take a derivative, I need to do that substitution. So let's, oopsies. Okay, let me fix that. Yes. So that we can maximize, optimize. Nice. So let's set this. Let me change the color. I'm gonna make it blue. I'm gonna say that A is equal to 1/2 pi r squared. Okay, so that's the semicircle. That's the area of the semicircle plus the area of the rectangle. And we found out that the h is actually 12 minus 2r based on the perimeter, right? So that's going to be 24r minus 4r squared. Okay, I think I did that right. So I can combine these two since they're both r squared. Or I could keep it separate either way. Yeah, let me just keep it separate and do a prime being pi r plus 24 minus 8r. Now I can put them together. It looks a little bit better. 0 equals r times pi minus 8 plus 24. Or should I bring the 8r minus? Yeah, I think I'm going to bring that over to the other side. I'm going to say 8. Hold on. I can leave it like that. Actually, no, because pi minus 8 is going to give me a negative number. So let me just say 8r is equal to pi r plus 24. Okay, and then I say 8r minus pi r is equal to 24. And that would give us r times 8 minus pi is 24. So r is equal to 24 over 8 minus pi. Okay. That look about right. How did I get 4 plus pi? Something I did wrong. H plus R. Half the circumference of a circle is pi r. So 2h plus 2r plus pi r equals 24. Let me see if I have the same thing. Four r plus 2h. Okay, so I messed up on the perimeter calculation. So that's the reason why I'm not getting the same thing. So the solution I'm going to just put down because I don't want to do it all over again. H is equal to 3.3. H equals R? Now see? Two point three six. Didn't H equals R at some point? That was no. I said that it was a 2R because it's the same as the to make it square. Anyway, so the H is about 3.36. And R is wait, what? Somehow I'm not liking that answer. Okay, so tell me if you got the right answer. If I'm wrong, tell me I'm wrong, and how you got to your answer. All right. I want to thank you so much for tuning in. Until next time. Bye.